Saxon Advanced Mathematics, Lesson 14. Look, you guys, it's our friends, sine, cosine, and tangent. We're going to review them, and we're also going to review rectangular and polar coordinates. Remember that this is review, so we're covering what you studied last year. You're not going to charge off into new unknown lands yet. We're just going over what we know. Okay, remember that these trig ratios, that's all they are, is ratios, you guys. I'll show you, remind you of that in a minute. They relate, as we're studying them so far, only to right triangles. We're going to expand that later on, but for now, it's only right triangles that we're talking about. And when we talk about these triangles, we give each name a certain, each leg of the triangle, each part of the triangle, we give it a certain name depending on where we're standing. I always orient myself thusly. I'm standing, and I imagine the triangles being that big and me being that small. I'm standing by what I consider to be the toe of the triangle. They might be over here, right? It might be oriented in that direction, but in this case, I would be oriented to the one that's on the ground, honestly, is how I think of it, okay? So this one is going up, and here's the angle that we're interested in. Because we're talking about sine, cosine, and tangent, we're always talking about it in perspective in relation to one of the angles. So if we were standing up here, then sine, cosine, and tangent would be different. So we're down here, we're by one of the pointy angles, not the perfectly square one, and we're choosing the one that's on the ground. So this is called the opposite side, because it's opposite the angle. And this is called the adjacent side. Adjacent means next to. It's like our neighbor, right? Because it's on the side close to where we're standing. And this is the easy one. It's the hypotenuse. Okay? This sets up our vocabulary for these different, we call them trig functions, but that makes them sound hard, and they're not. All that these guys are pairs of ratios composed of combining these sides in different combinations. So when we talk about sine, we're just talking about the length of the opposite over the hypotenuse. It's just a ratio of those two sides. And what's interesting is that once you choose a certain angle size here, like let's just say it was 30 degrees, no matter how big or small the triangle is, those two sides will always be in the same ratio if that's a 30-degree angle. So they might be huge numbers or tiny numbers, but once you reduce, it'll be the same number. And that number's built into your calculator. Oh my gosh, amazing. Okay, when we talk about cosine, that's a different pair. In that one, we take the adjacent side and put it over the hypotenuse. Again, as long as this angle stays the same, no matter how big or small the triangle is, the adjacent over the hypotenuse will be a certain ratio that, again, is programmed into your calculator. And then tangent, uh-oh, Gracie wants to go out. Hang on, just let me write this down. Do you hear her crying? And tangent, adjacent. I spelled it wrong. Okay? So there are the three pairs that are compared, and we give each ratio a special name. I mean, we'll talk later about why they have those names, but these, just consider these to be random. What's important is that you understand we're just making fractions of those pairs. Okay, I'll be right back. I mean, just to keep this interesting, I'll have to go get her in a hot minute because it is like 1:45 a.m. and everyone else is upstairs and I can't let her stay outside and bark. That would be very uncool. Okay, so this is all this information. We memorize this and I have some tools to help you do that. First of all, we abbreviate these with the first 3 letters. So sine, cosine, tangent. We don't say sin, cos, and tan. We say sine, cosine, and tangent, even though we're working off the abbreviations. Now, we memorize these by the first letter of each of these words, right? Here's the way I memorize them, and I like it. You guys, I'm sure, are familiar with Oscar the Grouch from Sesame Street, right? He's the green fuzzy guy that lives in a tin can and beats people up. But as far as I know, he never comes out of his tin can, his garbage can. He lives in it, right? Because he's a puppet. Sorry if I just ruined your childhood, but he's a puppet, so he lives in a trash can. Now, you also probably know Arthur, I think he's an anteater, right? Arthur and what's his sister's name? DS, I need you here right now to help me with this. But he's a little anteater. We read his books. I think he also has a TV program, but he's Arthur the Aardvark. Now, one day, Arthur was walking down Oscar the Grouch's alley. You know how he lives in an alley on Sesame Street? And Oscar jumped him and started beating him up. And I want you to imagine those green fuzzy paws. I wish you could see all of me, but I'll show you can see my hands. The green fuzzy paws are choking the poor little Aardvark's neck, and you know he's got a little he's got the little wonky little glasses and stuff. Arthur does. Oh, he's just a little nerdy guy. Okay, Gracie's barking. I'll be right back. Just keep that image in your mind of Oscar choking him. Go around, Sue. Okay, I'm back. All right, so that moment is frozen in your mind of Oscar the Grouch choking little Arthur the Aardvark, and that will help you remember these because Oscar had a hold over Arthur. That's the way I remember these. Other people have other techniques, but I'll tell you what, I'm going to always be talking about this. Like when I talk about sign, I'm going to say, oh, it's Oscar had. Sorry, that's what's in my brain. And so join me in my world of puppets choking fictional characters because it's compelling and exciting. And whoever said math is boring, not me. Okay, so we can use these ratios and our calculators to solve for missing pieces in triangles. Example 14.1. One thing I hate about teaching this, and I need to do better, is I use the calculator in my phone, which I invite you to do as well. But my phone is used to record this, so I can't really do that. I can't show you both at the same time. Okay, so here's our diagram, and we've been asked to find A and B. All right, so we start by going alphabetically, and I know that A is the adjacent side, right? I can figure that out. So I know that I would like to compare the adjacent side to the hypotenuse because the hypotenuse I know. So I need to use the ratio that compares adjacent to hypotenuse, and that's cosine, right? A hold. So I know that the cosine of 36 degrees is going to be equal to A, the length of that side, over the hypotenuse, which is 6, right? And so to solve for this, I can say 6 times the cosine of 36 degrees equals A, right? I just cross multiplied essentially. This is over 1. So I just brought this up over here. Now I'm ready to enter it into my calculator, and here's what I want you to do. I want you to enter 36, then hit cosine, and then I think you have to hit equals too, right? And then times 6. And the answer you should get, whoops, A equals 4.854. In your homework, I'd like you to round to 2 decimal places. That means you need to find 3 and then round back there, right? Rounding to 2 decimal places doesn't mean finding 2 decimal places. It means finding 3 and then rounding. All right, so this should be the answer for the length of side A. And then for side B, that's the opposite. And we want to relate that to the hypotenuse. So that is Oscar had. So we'll say the sine of 36 degrees equals B over 6. And then we can go 6 times the sine of 36 degrees equals B. And then when we solve that, the value you should get is 3.527, rounded. There will be some rounding differences. We'll talk about them as we go. Basically, I don't care about rounding differences if you're close. And within a couple hundredths of a point is definitely close. Okay? So this is a basic example of how to use the trig functions to find missing pieces. Let's do another one. I hope you guys didn't fall asleep when I was dealing with the dog. That was exciting, right? Okay. Here's another one. Find angle M and side X. Wait a minute. I want the angle. John did not give us the angle this time, right? So, shoot, I wish I had a calculator so badly. I want to show you this. I'll figure out a way to do this, you guys, so that I can work a calculator at the same time. Okay, so this time we're not given this angle, so we have to be clever like a fox. So we take the numbers that we do have, we figure out what side are they. Oh, opposite and hypotenuse. Oscar had. That means the sine of m degrees, whatever that might be, is opposite over hypotenuse. Okay, that's cool. But this doesn't look quite right because we don't usually have fractions in our trig problems. But if we take 3 and divide it by 7, then we get 0.42. I'll just give you all the digits. 4285714. That's what John tells us, all right? You can do that division and find it easily. Now we can use what's called the inverse sign. And it's this button. And it's usually you have to hit second to get to that second set of function keys, and then you'll find this one. What that does is that's when we know the decimals and we want the degrees. Okay, so the regular buttons, sine, cosine, and tangent buttons that are usually in the first set of buttons, That's when we have the degrees of the angle and we want the decimal number, and then we multiply that decimal number against the actual length. But if we have a situation like this one, these are my little buttons I'm drawing, where we have the decimal, right? Because we took 3 divided by 7 and we got the decimal number, but we want the degrees associated with that. Then we use the inverse buttons. This is always confusing. And I'm sure you figured it out last year, so you'll figure it out again. But there's just a little reminder of which one you use depending on which information you have. Okay, so when we enter this number and then the second and then the inverse sign button, what you'll get is that M equals 25.38 degrees. The degree sign will not come up in the calculator, but you'll get the number, okay? All right, and we rounded this. This is rounded. These trig values, the decimal numbers, are quite long. I don't recommend that you round and copy them. Just do your calculation right off of that. This is not a good example, but I'll show you what I mean when we get to another example. Okay, that's the only example for now, though. We're going to talk about angles of elevation. The main thing I want you to know is that in trig, we're looking a lot of times at the polar coordinates, right, or the plane. This is our x-axis. That is what we call the horizontal, or the horizon in trig. And remember that when we measure, we always go up and around from there. And what that creates is what we call an angle of elevation. But sometimes, when we're feeling real crazy, we'll go down from the horizon, and that's called an angle of depression, which sounds sad, but it's not. Okay? So that's just a little terminology. Let's use trig to solve more of like a word problem. This is one problem I like. It's fun. Example 14.3. This is a long lesson, and me going to get the dog didn't help. A man is 6 feet tall. A man 6 feet tall is 200 feet from a tree, and he measures the angle of the elevation to the top of the tree as 11 degrees. How tall is the tree? Okay, let's look at what we've got here. Here's a man. He's 6 feet tall. He has no arms. There, now he's got arms. He's looking at a tree. Those are some superior tree drawing skills. And let's assume that they're on a flat plane. And the tree is 200 feet away from him. We're going to assume that's right down the middle. Right down the middle of him. And right down the middle of there. That is from here to here. That is 200 feet. And the angle of elevation is 11 degrees. Now, this is the part I don't like. They're suggesting, the tree, I'm sorry, I didn't write this down. The tree's 20 feet, right? Double checking. No. We don't know how tall the tree is. Okay. So what John suggests we do is that we assume his eyes are looking at the tree right there. And then this becomes, to the top of the tree, becomes a triangle. This, we're told, is 11 degrees. And we are assuming, this is the part I don't like, we're assuming that the base of this line is at 6 feet, but your eyes aren't at the top of your head. So that doesn't make sense to me. It should be the guy's like 6'3", And then his eyes are at 6 feet. But that's me obsessing over the question too much, all right? So what we want to do is we want to figure out how tall the opposite side is, and then we want to add it to this amount, which we're assuming is 6 feet. All right? Now, I take issue with this problem a little bit because I don't think it's very precise. But if we accept this diagram, then we can do it. And we can say, let's see, we want the opposite side, so we're dealing with, and we've got this side because this is 200 feet here. So we've got the opposite and the adjacent sides. We don't have the hypotenuse. So let's use tangent. The tangent of 11 degrees is going to be equal to the opposite, which is x, we'll call it x, over 200, because that's how long the adjacent is. And this is over Arthur, so opposite adjacent. All right? And then we are ready to cross multiply. So 200 times the tangent of 11 degrees equals x. That means we'll use our regular buttons, not the sign to the -1, not the inverse buttons, but the regular buttons to find the decimal number that represents the tangent of 11 degrees, and then we'll multiply it by 200, and our answer will round to 38.8. And then we will, that's this, right? That's x, and then we will add the 6 feet to it. And so our answer will be that the tree is 44.88 feet tall. Other than the part about the eyes, I love this problem because it is so real lifey. Okay, here's another one that's like it. An airplane is flying at an altitude of 3,000 feet above ground. Okay, so here's my airplane. It's so far away, it's just a dot. It's 3,000 feet above ground. The pilot sights an object on the ground at an angle of depression of 26 degrees. Okay, so remember, an angle of depression is measured from the horizon. And so he sees, let's say it's a hanky. It's on the ground over here. And he sees it. The angle of depression is 26 degrees, right? That's what that term means. All right. What is the slant range from the airplane to the object? Okay, so we want to know this. This is the slant range. Term we haven't used before. So let's convert this into trig talk. The slant range is the hypotenuse. This side is the adjacent, right? And the angle that we'll use for this triangle is not 26 degrees. It's 90 minus 26 degrees, right? Because this much has to be 90. And we need to subtract that much. So this angle is, what is that? Let's see, 64 degrees? Yes. So this is the size of the angle that we'll use for the trig calculation. The 26 just helped us get to it. That's the angle of depression. So that's the amount that it measures down, which we just talked about. All right. So now what do we do with this? Let's see, which trig function do we want to use? We've got the adjacent and we need the hypotenuse. That sounds like cosine to me, right? A hold. So cosine, and sometimes it helps me to do this. I just write the ratio out, and that helps me set it up so that I know the cosine of 64 degrees is equal to the adjacent over the hypotenuse. Okay. This one takes a little more algebra to straighten out. Basically, I'm going to cross multiply these and let them, and then divide back. Look, if we multiply both sides by h, and those cancel, and then I want to divide by the cosine of 64 so that all the numbers are on the same side. Okay? So, our hypotenuse equal, this is a little bit confusing just because we had to do some algebra to rearrange it. And then it's also a little bit more of a pain to do on the calculator because you really need to use the parentheses. So I'd enter 3,000 divided by, then I'd set up parentheses and I'd do 64, and then I'd do cosine, and then I'd do close the parentheses, and then I'd do equals. And what that should get you is that the slant range is 6,843.52 feet. And that's the right answer. This is the right answer also. Okay? If you're having any problems with operating your calculator to get these answers, we will talk about it. You can message me right away. You guys don't have to wait until our video chat to ask me questions. You can send me problems that you're confused about any old time. So that definitely goes for this. If you're having any trouble with your calculator, message me and we will talk about it. Okay? So these problems used angle of elevation and angle of depression with trig. And now we have two more problems. I know this lesson is going on and on. We're supposed to convert what in the world? All right. Now, what we've been given here is a pair of coordinates that we recognize as being rectangular coordinates. The I and the J is a little weird, and we don't see that totally often, but we know that this is a plus or minus to the right and plus or minus to the up, right? Up and down. Usually we see these as R and up. So we can rewrite this, if it helps us, as minus 3R plus 2U. Remember that? This is just an alternative notation. And I like that John mixes it up because that helps you get used to different systems, and then in future classes, you'll be fine. Polar coordinates are written differently. In here, they have an angle that tells us the direction. And remember that that's always measured up from the x-axis if that number is positive. We'll get to if it's negative. This number is a distance. There's a number there. And that represents the distance from the origin to the line of the angle. Okay? Once we set the direction of the angle, then we draw a line like that, and then we measure out for however long the distance is. All right? So this has these two components. So we did a lot of these problems last year where we have to convert the two from rectangular to polar or back again. So the first thing we always do is draw the picture. So this is a minus right and 2 up. So that tells me it's going to be third quadrant. And what I do is I just minimize my draw. I don't draw all 4 quadrants. I zoom in on the one that I like. So minus 3. And you know what? Here's the thing too. You don't really have to measure these. You can just say, okay, we're calling that 3 and that 2. And so it is going to be, our point is going to be here. And so that is, this sets the angle, this set the direction, if you will, this sets the distance, and then we take that point and we just attach it down to the horizontal axis. Our triangles always connect down to the axis. Now we know that the length of this side is 2 and the length of this side is 3. Right? Because that's how we met. That's what we said. We don't even have to measure it and draw the gauge. I did it to make you feel like it was familiar, but we don't have to do that. Now, what we don't know is this angle, and we need to know the angle, right? Because we have, in order to write this in the proper format, we actually have to have this angle. But if we can find this angle, then we just subtract it from 180 and we're golden. We need to find the angle and we need to find the hypotenuse, because the hypotenuse represents the distance from here out there, right? So I'm going to just add that to my notes here. Hypotenuse. Okay? So we need the other 2 pieces of information in order to get it. Now, lucky for us, we've got another tool that we can use, and that is Pythagorean theorem. We can use that to find the hypotenuse, right? So to find the hypotenuse, we're going to say that 2 squared plus 3 squared equals h squared. 4 plus 9 equals h squared. And that tells me that h squared equals 13. And h equals the square root of 13. I'm ignoring the negative root because this length can't be negative 13. So now I have a value for my hypotenuse. I like it. Now we need to find this angle. Now I can use this number if I need to, but I've got 2 much more well-behaved numbers over here. So to find, and what we usually do is we use theta, that Greek letter, for our missing angles. So to find theta, or the measure of this angle, we know that this is the opposite and adjacent, and over Arthur, that's tangent. So we can say that the tangent of theta equals opposite over adjacent, which we need to report in decimal form. It's 0.667, right? So now we need to use the inverse tangent button to enter 0.667 and then hit tangent of -1. And that will give us sorry, I'm thinking 33.69. Theta should be equal to 33.69. That's this part, right? So that's not the part that gets written in here. The part that gets written in here is this. So we need to take 180 and subtract, right? Because this angle is the supplement of this angle. So here we go, a bunch of subtraction. And again, I expect you to do these calculations by hand, you guys. 10 minus 9 is 1. 9 minus 6 is 3. 7 minus 3 is 4. Oh, wait. I didn't write enough. This is the 7. 9 minus 3 is 6. Yes. Okay. So this is the measure of this angle. It's what we got for theta subtracted from 180. Okay? So one way to write this is to say square root of 13 at 146.31. No, I can't say it that way. 146.31. That is correct. Okay. Now, we're supposed to write this 4 different ways. So my answer is going to have 4 boxes. Oh, Lord, John, how hard do you need to make this? Okay, what if we want to... Oh, wait, I left a digit out of this. 146.31. What if, instead of going that way, what if we measure our angle by going that way? Right? Okay, well, that would be square root of 13, but instead of being 146, it would be 360 minus that. So I'll do that right over here. It's 360 minus the 146.31. So let's see what we get. Go ahead and do the subtraction too. Yep, that's the number. So that would be minus 213.69, because remember, when we see the minus in front of the direction, that tells us to go in the opposite direction. All right? So there are 2 values for this point, but remember that we can also put a minus sign in front of the distance. And what that does is it says that we're originally going to send our reader to this point, and then when we say, oh, no, just kidding, it's minus, then they'll go in the 180 opposite direction, right? So that means we need to find the directions to steer our person to this point and then put a minus sign in front of it so that they know, oops, back up instead of go forward. So how do we find that distance? Okay. Well, it will be this same measure. All right, let me extend it. This angle is equal to this angle. It just is a negative. So that angle we found was 33.69. So if we write this as negative 33.69, then we'll go down just that amount. We'll go here, and then we'll back up on that straight line. So this is the 3rd option, the trickiest option. And then the other way would be that we're going to do this backing up thing again, but this time we're going to send the angle like so. So it will be a positive angle measurement, and you're just going to have to go all the way around to here, and then when we get to there, well, it says back up. That's what our minus square root of 13 says. So this purple angle is going to be 360 minus 33.69, because we're just backing up that same amount. So we haven't done that subtraction anywhere. Let me work up here. 360, the whole circle, minus this much, which is 33.69. That should give us what we need. 10 minus 9 is 1. Sorry, I'll be quiet. You do the math too. Yes. There are 4 ways of stating this same point in polar coordinates. Instead of rectangular, we've used polar, and there are 4 different ways to do it. Holy cow, that's a lot of work. All right. And then the last problem for this lesson, oh, can you believe it? We have finally made it, is I think a little easier. It doesn't have all of those 4 options, so that's a step in the right direction. 14.6. This time we're given polar coordinates. Minus 13 is our distance at a direction of minus 253 degrees. And we want to convert that to rectangular form. All right, this one's tricky. So let's think about what angle it's gonna be in. 253 degrees to the minus. Okay, each one of these is 90. So there's 90, 180, 270. So that's gonna put us somewhere like here, roughly. But, right, it's minus, so we're going in the opposite direction. We're gonna be somewhere in the 3rd quadrant, but it's minus in the direction also, so that means we're gonna go this way. So that puts us in the 4th quadrant. So now I'm going to draw it again. I'm gonna make this bigger because I have to go up here. Okay, so 253, this much is 180, right? This quadrant and this quadrant is 180, so let's see how big this angle is actually gonna be by subtracting 180. It's 73 degrees, so that means, this is too confusing, let me draw it again. 90, 180, plus another 73 degrees gets us to that place. But instead of going in this direction, we actually want to go in this direction, right? Because it's minus 13. So our point is down here, let's just say. All right, we draw our triangle back like this. We know that this distance is 13. And now we have to figure out what this angle measurement is. Well, this one should also be 73 degrees because those little angles are the same. So our hypotenuse is 13 and our measurement for this triangle, our theta, is 73. Whew, that was a lot just to figure that out, wasn't it? Now we're still working to get our coordinates, and we usually do this measurement first, right? Because we're trying to do a right and an up, if you will. We usually call this one A and this one B because we always do the x-axis first and then the B. And we know that these 2 sides of the triangle are going to give us exactly the measurements we want. So we know that this is the adjacent side. We're standing here. This is the adjacent side. So the cosine of 73 degrees equals A over 13. Cosine because we're using adjacent. And once we get in this buzz of doing these on an ongoing basis, you'll know that we always start with cosine first and then we do sine. And so then the second value will be the sine of 73 degrees is equal to B, the opposite, over 13. Okay, now we can just clean up the multiplication on these and we'll get A equals 13 times the cosine of 73 degrees and B equals 13 times the sine of 73 degrees. Do this in one step in your calculator. 73 cosine times 13. Don't stop and round here because that will just make your answer less precise. So all in one calculation, enter 73 cosine times 13 equals, and write that value down. John often rounds in kooky ways. Don't get me started. The cosine, this is 3.80 according to John's calculation. And this is 12.43 according to John's calculations. So we're ready now to write that in the preferred style I like is, we're here, so this A is going to be a positive value, so it's going to be plus 3.80 to the right, but now we're going down instead of up, so it's going to be minus 12.43 to the up, right? This is plus right, this is minus right, this is plus up, this is minus up. Remember that little head game? If you want to use John's terminology that he used on this, you can write 3.80i, and he uses, some mathematicians like to use the I and the J, and they put a caret over the I so that it's not confused with an imaginary number I. But then, once they've committed to that little caret thing, they do the same thing to the J so that they match. I'm not really a fan of this. I much prefer this. In either case, this is the right answer. Yay. All right, lesson 14 finally is in the books. I hope that was a review and not an avalanche of new material. We're going to be building on this. We're going to get lots of practice. So again, ask me questions. The sooner the better. You can ask me during the video chat, but you do not need to wait till then. Fire away. Send me questions by email or text. Laura and Vivian, if you want my phone number and you want to text me, it is on your assignment page. I don't want to show it because it's a public video, but if you look on your homework checklist, it's right there underneath my right thumb, so you can find it, all right? But message me anytime. You do not have to wait until our video check-in to call me. All right, beautiful. Lesson 14 has finally come to a peaceful and harmonious conclusion. I'm so glad we had this chat together, and always think of Oscar had a hold over Arthur. He's choking him, you guys. He's leaning over the top of him and he's choking him. It's a sad story, but it's a beautiful image. Well, no, it's not. It's a violent image. I apologize. I think I should stop now. Goodbye.